And finally, we have a question, an actual IB question here. So first, we're supposed to sketch a graph below of the expected rotational speed versus the distance r of a galaxy. So basically, we're supposed to do what we just had before, right? So then it goes kind of like this, and then kind of like this. Something like that. That's what's expected. Sketch the observed one as a dotted line. Ooh, okay. So remember what we see? We actually see something that goes, matches it here, but it goes pretty flat. Explain why the observed graph is evidence for it. Well, you could say rotation is faster than expected. Right? You could say that. It's faster than expected. Because of that, you could say more mass, you could say, is needed, I guess we could say, right, to keep the galaxy together. I guess you could say gravitationally attracted, but, you know, keep the galaxy together. This mass can't see it. So, well, you could say this mass is dark matter. Right? So that could be a very short version. You should probably explain more detail than what I just did, but something like that. And state two different types of dark matter. Remember, we got machos, and we have WIMPs. Right, so those are those two different kinds. That's good enough. I mean, these kind of questions, they're not going to ask you that much detail. I guess you could be asked for the derivation, kind of. So, I mean, it's nice to know the derivation, but I think it's just really neat to know that this is how we observationally know there must be more mass there than we're actually seeing. This just blows my mind. I love hearing about this. I mean, what a great time to be in science, or at least a great time to be alive, when we're trying to figure out all this cool stuff.